So what I do is I study past climate change. It's called palaeoclimatology, and the aim really of my research is to look back in time and see what the climate was doing in the past and how that might influence climate change in the future, that kind of thing. At school, for my A-levels, I did geology, economics and German. Geology obviously was like the major influence in me at university, and then going on to do a PhD, and really got me interested in looking back in the past. What I thought was also, or has been really useful for me, is having a second language. I think it's definitely allowed me or given me more opportunities. So as I said, I think the main influence to start with was my geology A-level, and the teachers involved in that, running that course, were really influential in me. And I went on to do geology as my degree at university, and through that is where I really decided that I want to continue with research and do a PhD. I did a year abroad studying in the United States, which was another major influence, and just allowed me to kind of broaden my horizons in terms of research at different universities, and pushed me towards or down a path that made me focus more towards research, and that kind of led me towards the PhD idea.
My favourite!
So one of the things that was really useful for me was during the summer of my third year at university, I did an internship at the Natural History Museum. So I got to work with one of the paleontologists in the department there. And I basically worked on the collections. I worked on reorganising some of their collections down behind the scenes at the Natural History Museum. And I also did some work picking out dinosaur teeth from sediment. And it was just a really good way for me to meet people, within the research community, but also to kind of understand what it was like to be part of a research team and that kind of thing. So that kind of three parts of my main day, if I was kind of doing the full spread of things. So I spend a lot of time in the lab, washing sediment and picking out what we use in my research, which are microfossils. So I spend a lot of time at the microscope picking those out, and then once we've actually picked those out, we actually take them down to the proper chemistry lab, and we actually analyse them for the various different chemical analyses that we're looking to do. And then another aspect of my research is obviously keeping up to date with all the scientific literature that's out there, and trying to kind of build a story combining my data with data that's out there already. So there's a kind of variety between lab work and more reading-based stuff, but then also I get to do a reasonable amount of traveling. There are different universities around the country that have different lab equipment that we can use, so sometimes I have to travel down to a different university to use their lab equipment, or I get to do a lot of conferences, and that's where I get to do one of my kind of enjoyable traveling, going to interesting places around the world and presenting some of the interesting data that we produce. One of the best opportunities I had so far was to spend about a month in Italy at a palaeoclimate conference. It's kind of a student conference/workshop, and I spent a month in Italy basically having lectures and seminars and giving a poster on my research as well. And the stuff I have lined up for this year should be pretty exciting as well. I'm going to Spain twice, and also hopefully going to a conference in the Netherlands, and potentially also a conference in the United States as well. So there's definitely opportunities to travel, and that's something I really enjoy as part of it. So the main focus, as I mentioned before, is looking at how past climates evolve and change, and obviously at the moment, with global warming and climate change happening now, it's important to understand what happened in the past as well. So the main focus of my PhD is looking at the North Pacific Ocean and how CO2 might have interacted between the ocean and the atmosphere in the past in that region. And so what we do is we take sediment cores, which are cores that have been drilled from the seafloor, and we find these little microfossils in them, and we analyse them and work out their chemistry. And from their chemistry we can actually calculate the amount of CO2 that might have been coming out of the North Pacific over the past 20,000 years, which is the time period that I'm looking at. And so that's kind of in its early stages at the moment, but at the moment we're seeing some interesting kind of data coming out that's showing maybe the North Pacific played a bigger role than has previously been thought during the last kind of 20,000 year period. I think, I mean, all of this climate change research is really, really relevant, especially because of the transition that we're going through today. What you'll find is that actually in a lot of climate models that exist today, a lot of the data that gets put into that actually comes from research that's been on studying past climate change, or climate change that's happened very recently, goes into those climate models. In terms of things like raising awareness for climate change or environmental impacts, presenting this work, sometimes I've had the opportunity to present some of my research and just some of some of the science on climate change to my old school, for example, and just having that kind of outreach towards other schools and that outreach basis really helps, I think, raise awareness for some of the climate change that's happening today. No, you definitely face challenges on a day-to-day basis. I think when you're doing a PhD, it's not often the case that everything works out perfectly when you're running samples in the lab or when you're washing samples or picking samples. So, for example, some of my sediment cores don't have very many microfossils in, and so they probably don't have enough for us to run them for a chemical analysis, and so we have to think of other things we can do. There's still a lot of other data we can get out of our sediment cores, and so things don't necessarily always go to plan, but there's always kind of a way of getting around that and using the data for something else. I melted some tongs once.
Oh, nice.
Well, they're now stuck up on my notice board, so as a reminder for me never to put nylon in acid again.
Excellent.
To enjoy doing this, I think you need to be someone who has an interest in science. You need to have, you need to enjoy studying the sciences, chemistry, physics and maths and biology. But also you just need to have an enjoyment for kind of the outside world and the natural world as well. I really like the outdoors. I'm a very outdoorsy person, and that definitely, helps me when I'm, investigating. Even if not a lot of my work is spent outdoors, it's still, that thought that you're kind of working towards environmental change and climate change is definitely something that an outdoorsy person would enjoy working on. So obviously one route after doing a PhD is to go on and continue in academia. So the next step after a PhD is really to complete 1 or 2 postdocs, which are kind of 1 to 3 year research periods at a university or research institution, where you're basically researching something of a similar topic to your PhD, and then you'd hopefully go on to get a lectureship or a research position with the university. So another route would be to go into industry, and with doing a PhD that focuses on climate change and climate science. I think there's a whole range of different jobs out there that are applicable to what I've done, and so it really does set me up looking beyond kind of research and academia as well. You can join the GeoBus team.
Yeah.
So in terms of my hobbies and interests, like I said, I'm a very outdoorsy person. I'm also very sporty. I enjoy doing a range of sports, and that kind of fits in with my kind of outdoorsy nature. In terms of related more specifically to what I'm doing now, always been a fan of dinosaurs. It sounds really nerdy, but always been a fan of dinosaurs. I used to want to be kind of more hardcore paleontologist, looking at dinosaurs and mass extinctions and that, and it was looking and doing bits of research in that during my undergrad that kind of led me more towards paleoclimate science and what I'm doing for my PhD now.